Hey, thanks for watching this video. This is one class from the 2022 HVACR Symposium in Claremont, Florida. We have the symposium every year, and so to find out more information kind of upcoming, go to hvacrschool.com/symposium. Big thanks to our sponsors for this event, which was AccuTools and TrueTech Tools. They're the two title sponsors that made the event possible. This class is with Jim Bergmann. As many of you know, Jim is a very good friend and is really an expert when it comes to measurement, commissioning, and in this episode he talks about how to use the innovative MeasureQuick software in order to properly commission new systems.
We're going to be actually going over a little bit more on system commissioning. It's got some MeasureQuick in it, but a lot of it is actually about how to use MeasureQuick as part of a system commissioning process. Before we get started, I just want to talk about a couple things. You guys are going to meet, we got a new hire with us, Joe Medash. He's been out, he was actually a trainer for Retro-Tech. We just brought him on board here about a month ago at AHR. He's going to be helping us with the booth today, so stop by and see Joe. And then for those of you that have been using MeasureQuick for quite a while, we are coming up with two new programs. One is a certified MeasureQuick user, and the other is a certified MeasureQuick trainer. We have a lot of companies across the country that are trying to incorporate MeasureQuick into their businesses, and we just can't get to everybody anymore. We're over 65,000 people on the MeasureQuick platform now that are using it day to day. There's hundreds of thousands of tests processed a month on MeasureQuick, so it's getting pretty big, and we're looking for help on the training side. So if you're interested in that, again, Joe can help you with that. And then the QR code, you could probably scan it from here even, but Joe's got it up on our booth. There's a little quick survey about MeasureQuick, and if you take the survey, there'll be 20 qubits added to your account, so you can actually try all the full features of MeasureQuick and get that going. We're going to talk about commissioning, and commissioning, a lot of times what we're talking about is setting up a brand new system to some designer specifications. The reason that most of you may have never heard of commissioning is because as an industry, we don't design anything, so there's nothing to set it up to. Right? If you think about like when we get engineering prints and things like that, and somebody actually does like, let's say a full heat loss calculation, that's where we're doing room by room and balancing it out and getting the right airflow to the right space, setting the airflow to the right range. In other words, when you do your manual S, you may have to set it to 400 CFM a ton, or maybe 450, or maybe 350, or maybe something in between there. And that is what a commissioning process is. It's setting it up to designer specification. Retro-commissioning is commissioning to the past design. So in other words, the designer set up the spec. We're just going to go back through it. Maybe we'll do a cleaning of it, clean the coils, clean the condenser, clean the evaporator, and then we'll retro-commission the system. And then you'll hear also, recommission. That's recommissioning. And then we'll talk about retro-commissioning. And retro-commissioning is like you get in a school system, they've torn down the walls, they've re-engineered everything, they just moved runs around, they moved thermostats, and now we're taking an old building and we're taking it up to a new standard, right? So those are the three you're gonna hear on there: commissioning, recommissioning, and retro-commissioning. Now the challenge we've got as an industry overall, and this is a huge opportunity right now, is that you have at least one fault in 70 to 90% of systems. So just want you to stop and think about this for a minute. And if you include duct leakage, it goes up to 90 to 100%. So 7 out of 10 to 10 out of 10 systems you guys go out to today have at least one fault. Most of them have multiple faults, right? You guys that are going out to do the $49 tune-up on an air conditioning system, you're out there because you're doing a service call to find opportunities. If you aren't finding those opportunities, you're leaving a lot of money on the table. And these are real opportunities that customers need fixed. A lot of younger techs go out and they're missing a lot of these faults in our equipment. A lot of them are airside related faults, charge related faults. So it's really critical that we're able to identify those. And the question is, how do we close that gap, right? So the MeasureQuick field process, I want to go over this in some detail. And obviously the first step would be, we think to start the system and to get things stabilizing. But here's where I want you to completely stop what you're doing and think about what's going on with the entire system. The challenge is everybody in our industry they try and fix everything at the appliance, right? You go out there, you do a startup, you're trying to set the airflow at the appliance, you're setting the gas pressure, manifold pressure, temperature rise, you're going through on an air conditioning system, doing the charge, but people don't take the time to look at the entire system. And so what we're going to talk about a little bit first is the visual inspection. And the reason I'm so adamant about some of these things is because if we're not thinking about systems, right? I get caught up here, right? The control system, the electrical system, the air distribution system, the condensate disposal system, right? Filtration system, the sealed system, our outdoor and indoor equipment. If we're not looking at this from a system approach, we're missing a lot of valuable information about that unit, right? Because if we're just going to swap a box out, we're going to end up with a lot of problems that we're going to overlook. And here's the issue. We have people every single day connecting MeasureQuick to systems, and they can't figure out why it's giving them flags on the system, why they're getting an airflow flag, a charge flag, a capacity issue. They're missing those issues because they aren't looking at it from a system approach, right? So anytime also during this commissioning process, we have a photo documentation section built into MeasureQuick. And you can document as you're going through this visual inspection, take photos of that and take notes. You can add notes by flipping the note switch on, and then you can tap the photos to view them full screen. But this is a pretty valuable part of using MeasureQuick is actually photo documenting what's wrong with the system. So let's start out with the control system. There's a fellow here, that Ohio fellow, we were talking about this just last year, put in a new Bosch system. And one of the issues that we found was he had a unconditioned crawl space underneath the house, some supply duct leakage. Thermostat had a hole drilled up for the wire to go up, obviously inside the wall. The supply duct leakage is pressurizing the crawl space, which is unconditioned crawl, sending air up behind the thermostat. And you put a brand new inverter system in, and the humidity is reading high on the inverter system. And it's reading high because we're pushing unconditioned air up behind the thermostat, and it's giving it a false high temperature, right? Now, you think about these kind of things, and a lot of people don't realize that that's going to cause excessive run times. In fact, a lot of you guys have probably come home from work, walked in your house, and said, dang, it's cold in here today, right? Because it's a 95-degree day outside. And what you don't realize is your thermostat's registering 78, so your unit's running continuously, but your air temperature is probably down to 74 or 76 degrees because you're getting air from an unconditioned space. And that's even more important today that we plug this hole up with some thumb gum because we have incorrect humidity readings on the thermostat also. A lot of humidity readings are incorrect because we're pushing, again, water vapor up through there. So you want to make sure when you're doing that, you're not using like paper products. Also, obviously, you can see we got excessive wire showing here, not properly secured, right? Electrical system. I don't know how many times I've gone out and seen guys put in new systems and they don't check from the breaker box. I highly suggest, whenever you're doing a new system, pull the cover off the breaker panel, inspect the breakers, inspect the connections, look for undersized conductors, look for loose lugs, look for damaged bus bars on there, right? Service disconnects. When you touch a service disconnect, it should not be warm, right? One of the first things I do when I walk up and I lift the cover on a service disconnect is put my hand on it to see, and Joe will say, put my hand on backwards in case I get shocked on there, right? But the idea behind it is you're feeling the service disconnect to see if it's warm. It should not have any noticeable temperature, right? And again, undersized conductors, loose lugs, loose fuses. So many guys will go out and they'll see a compressor's hard to start, and they'll put a hard start kit on that, or they'll put a soft start kit on that, and they're fixing a symptom, not the problem, right? So we got to make sure we're addressing those things. Air distribution system. This is probably the most overlooked part of the system because nobody wants to get in the attic and do this. So, again, straps not redone after installations, ducts not properly supported. Poor design, excessive flex ducts linked, right? Just general failure of the flex duct. It's breaking down due to heat in the attic. People will put the probes out. When we're using MeasureQuick, we're going to test from inlet to outlet. I'll show you that in another slide. A lot of times we see low sensible capacity. And again, if you're not looking at the entire system, you're looking at this thinking the software must be wrong. You're going to blame something else when it's actually a duct system that's got high sensible heat gain. Disconnected ducts, right? I don't know how many times I've seen this on systems where I've put my probes on there. Again, I see low capacity. I'm like, why am I getting this low capacity? Well, MeasureQuick will pick up duct leakage issues on there. So if you have a return that's disconnected, and let's just think about it, well, how would MeasureQuick pick up a return duct leak? What are some symptoms that we're going to see on that? What would happen to your suction pressure? If you had a return duct leak, you're pulling in hot air from an attic. Suction pressure would go way up. How about your temperature split? What would your temperature split do? Temperature split's going to go way down, right? So there's about 6, 10 things that MeasureQuick picks up that look in all these relationships that's going to see that problem. But if you dismiss that problem, you're dismissing an opportunity, right? Homemade transitions, no mastics, loose fittings, air leakage issues. Air leakage at the top plate. This is very, very common where somebody's framing in a return. You'll notice that insulation on the one side there is almost black, and it's because it's become an attic air filter, right? We're pulling return air through from the hot attic space. Again, erosion of the temperature split on the system, right? Unsecured panels. This is one we ran across. Somebody converted a rooftop unit over from downflow to horizontal. So the guy forgot to screw in the panels on there. And the way I found it was actually an auditory thing, because every time it would come on, I'd hear the panel drop down when it shut off again, right? Common problem. A lot of times we'll see, again, we're trying to fix everything at the equipment. Contractor puts in a huge, we call it the bad drop. Some people say big ass drop or on there. And they're trying to get better filtering of the air. But if you start tracking that back, and this one went all the way back to 2x4 joist space, and you ended up, it was reduced down to a wall cavity, a 2x4 wall cavity for the return. Huge drop, huge amount of static pressure on the return. And again, if we're not paying attention to that, we're going to miss it. Air filtration system. This is probably like the biggest epiphany I had in my career was how bad our filtration systems are in our industry. And this is one of the biggest opportunities. If you want a real opportunity that's going to make money for you and help your customers out, it's addressing what's going on at the return. We used to just put filters in to protect the equipment. If you really think about it, these were never meant to be IAQ devices to clean your indoor air and take care of your indoor air quality. It was always just, to stop rocks and bumblebees, right? And the filters on our systems were not that great. And I don't know how many times I've seen in our market, the one David and I are from, right, open filter slots in the basement. The filter doesn't care, or that slot doesn't care which side of the air, which side of the filter is pulling air from. It doesn't say, you know what, the filter is on the left, so please pull all the air from the left side. It pulls it from whatever side it can pull it from. And sealing up that filter slot and getting rid of the CAS depressurization, getting the air to stop bypassing the filters of critical importance. And this one here, this is an interesting thing. A lot of times we'll see the homeowner will go out and buy the 3M filter, nothing gets through the filter, including air filter. Why did they even take the plastic off of the filter? Because it didn't make any difference, right? That exacerbates duct leakage. So now, if you have a highly restricted filter at the filter inlet, it's going to pull more air through the leaks in the duct system. So again, you're going to erode your cooling. You notice on there, we're showing those 2 field piece probes. We're on the inlet to the return air filter grill, and we're on the supply, first supply. So that one up there, I don't know if we put a little no on there, but we should have where it says 75-degree air. But what we're showing there is basically we're testing from inlet to outlet of the system. Dirt bypassing the filter grill. How many of you guys actually take a minute and tape in a filter grill? It's a handful of you do. That's one of the most important things that you can do, right? If you stop and think about it, it's not complicated. But when you see that dirt around the edge there, that's because the filter started to bow in and pull in, and now we're pulling air around the filter instead of through the filter. So just putting a roll of painter's tape, and what I usually do is I buy it in bulk, and I'll just leave the roll right inside the filter grill for the customer. So next time they do it, they don't have to find tape. They just have a roll in there already, right? It costs a couple cents to do that. Make sure you have enough filter. This is one I missed for years, was undersized filters on equipment. A lot of times we look at, it's true. It's air temperature rise 30 to 60 degrees on a furnace, right? 30 to 60 degrees on a furnace. So quick sizing of that, like let's say we had a 3-ton air conditioner. You'd go, okay, well, 3-ton air conditioner, we calculate our CFM. Center of the rise here would be a 45-degree center of the rise. So 71,000 BTU output divided by 1.08 times 45 would tell you, well, you would need about 1,460 CFM for our heating side of the appliance. Now, what have you guys noticed on a 90, like if you go to a 97% efficient furnace, what's one of the things that we've noticed now that's happening? What's happening to the temperature rise on the furnaces? It's going way down. Yeah, in fact, my old furnace on my house was a 60 to 100 degree rise, my 90 plus. My new one, I downsized it. I went from 100,000 down to a 75,000 BTU furnace. My new rise was 15 to 45 degrees. My new center, my rise, required more airflow, even though my furnace was downsized several sizes than my old one did, right? So you start doing a quick check of the furnace, it's 1460, 16 by 25 filter, so you just take 16 times 25 divided by 144, that gives you square feet. It's going to tell you that that's 527 feet per minute. Anything in excess of 300 feet per minute is too fast, right? 500, if it's over 500 feet per minute, you really do need to address it. But all filter manufacturers go, wait a minute, I got a 4-inch filter on there. Doesn't matter. The reason you have thicker filters, so if you think about like HEPA, it's more restrictive. So you need more surface area to have that low pressure drop, but it has nothing to do with the filter face velocity. We're in Florida here, so I'm assuming somebody's been to the beach before, right? You take a little sand sifter, to sift and get shells and stuff out. When you have that sand sifter, what you're doing is you have to sort of, if you just pour the sand in, it doesn't just drain through. It sort of sits there, right? When you shake it a little bit, now it starts to sift. Well, it's the same thing when we have high filter face velocity. Instead of the dirt getting trapped in the filter, it actually sifts through the filter, right? And that becomes a big problem. Condensate disposal system. Where does condensate come from, first of all? What kind of water is that? Distilled water, right. Anybody here wear a CPAP machine by chance? All right. When you go to the store with your CPAP, do you ever see dirt in the bottom of your distilled water? No, right? We shouldn't have any dirt in a condensate trap. You should never, ever, ever have to clean a condensate trap. If you go, you're going, yeah, no way. Yeah. That's all we do in Florida is clean condensate traps. No, but think about it for a minute. Where does that water come from? Where does that water, it's distilled water out of the air, right? If you think about what's happening there, in order to have growth, biological growth, you have to have distilled water and what else? Something to eat, right? A food source in there. If you eliminate the food source by eliminating the dirt in there, you're going to eliminate your condensate trap cleanings. And if you're not finding an underlying cause, which is dirt bypassing the filter, undersized filtering, you should never have to clean it. So you got to figure out what's causing the debris, make sure your trap height's good, make sure your trap location's good, make sure your proper pitch. Condensate drainage issues, you likely have filter issues, right? And that's what this is here. This is also, we want to watch for rust. That's a pretty good indicator. When you're walking outside, you see rust coming out. This was full of rust on here. This one's not only a filter issue, but it's also a evaporator pan that's rotting out on there. Refrigerant charge issues, pretty self-explanatory. Caps left off. Installation issues, this is the bottom of an evaporator coil where it has no pan. Air's blowing by the evaporator coil. MeasureQuick will pick that one up also, right? So this is, you're going, wait a minute, I thought this was going to be a MeasureQuick presentation, and it is. This is a software program. It's designed to pick up these faults and problems on there, but there's nothing more important than you going through that system and doing a proper visual inspection first, because there's absolutely no reason to put MeasureQuick on a system or to start deploying your probes out or evaluating charge on a system with a dirty filter or dirty blower or plugged evaporator or plugged condenser. Yet how many guys, the first thing they want to do is go gauge up on a system and see and try and fix the problem with refrigerant? How many of you guys when you're young in your career added 4 or 5 pounds to a system, or me, I added 30 pounds to a system before you figured out the blower wasn't running, right? I mean, you go out there and you go, oh, frozen up, low on gas, adding gas to the machine, right? All of us have done that, but that's the last thing we should be doing. We should be going through and doing this visual inspection first, and that's where you're going to get the most out of the software. So now we're going to start the system. Things are going to take a little time to stabilize. While we're doing this, we're going to start gathering some information. Most people, it's very interesting. We have a huge number of users on MeasureQuick. We have 2 types of users. Those that have figured out how to make a lot of money with MeasureQuick. Most of those customers are seeing between a 40 to 60% increase in revenue per ticket. And they're seeing that because they're finding problems their technicians are overlooking, and they're pretty much eliminating their callbacks. We get other contractors, and this is where I was talking to somebody about this particular market in Florida, where they think it just takes too much time, right? Because their mentality has been, they go out there, Mrs. Jones has got no cooling. They walk out, they pop the cover off the condensing unit. They go, oh, bad capacitor, easy $300. Take the cap out, put the new cap in, push the disconnect back in, calling the boss for the next call. Literally 5 minutes, right? Now, you just created a whole heck of a lot of problem for your dispatcher because she doesn't know whether you're going to be 5 minutes or 5 hours. Most of the companies that are using MeasureQuick now, because they're putting their technicians through the entire process, they're finding the other problems that are wrong with the system. Just getting a system running does not mean it's running right. So while we're letting that system stabilize, we're going to start getting the information off that and putting it into the system. Low and high pressure near the service valves on there, or true suction, liquid line, near the service valve. Discharge line is optional, 6 to 10 inches. Outdoor air, we want to be out of line of sight of the sun here, so you can sort of see where we got the probes placed on there. Pretty typical of what you guys would be doing on any system that you'd be working on. If we're inside the conditioned space, there's two types of systems. We deal with a lot of stuff in our area which is inside the conditioned space. Duct leakage is not as big of a problem as you guys have in Florida when the ducts are outside the conditioned space. So outside the conditioned space, we can be in the return air drop. So you'll notice that probe's over here in the return air drop. And then we want to be 6 to 10 feet away in the supply air duct. You want to give the air time to mix. Most of us were never taught how to properly measure temperature rise or temperature drop across an appliance, because how many of you guys went to school in your programs or trade schools, or even if you go to a supplier, you walk out there and they were teaching you how to test the system and there was no ductwork attached to it, right? Huge problem, right? In fact, I remember calling my dad when I was a kid. I'm like, Dad, the boss told me to look at the heat exchanger, but there's an evaporator coil on top of it. How do I look at it? Because I had never, every system I worked on in our shop, I could just look in the top and see the heat exchanger. I never really thought about not having access to it through the ductwork. So really important to do that. The other thing really important to do, make a mental note. Look at the thermostat, see what the temperature is in the space, and look at your return air temperature and make sure that they're the same. If the return air temperature is substantially warmer than your conditioned space temperature, you've got a return duct leakage problem you want to address, right? If the probes are outside the conditioned space, so here what I'm showing here is like a garage, pretty common in Florida. I do not want to be in that return air drop. I want to go inside the house and put that actually at the return, okay? Because we want to test from inlet to outlet on that system. So what we're trying to determine there is if we have duct leakage. So if it's 72 in the house and I'm seeing 72-degree return air, but I'm a 75 at the space, right? Now this is what's crazy. There are so many techs out there that will see a poor temperature split. They'll see like a 16 or 12 degree split. What's the first thing they do? Walk in and slow down the fan, right? Oh, temperature split's wrong. So nobody ever set this, the fan speed's too high. They slow down the fan and they just missed the duct leakage issue. Completely missed it. Because they're seeing a 75-degree return air coming in there that's hot air leaking in from that unconditioned space, right? So probe placement is absolutely critical on the software to make sure it comes out with the right answers. Same thing here if we have an attic installation, right? We want to have the return air measured at the inlet to the filter grill, and then the really, really critical is to get that probe up inside the supply, okay? If your capacity is low, you're going to look for duct leakage. Short cycling of air. I've been bit by this more times than one, where I've gone up, pulled down the attic stairs, or not paying attention to the attic stairs. You're seeing you put the probe at the ceiling. How many of you guys have walked in, put your probe at the ceiling, you're using your smart probes, you see it's 78 degrees, and you go, oh yeah, warm air is warmer, and it rises to the ceiling. No, it doesn't. What you've got is duct leakage. You got can lights that could be leaking, you've got an attic that could be leaking, and again, so many of us dismiss. We see something and we just make up a reason why it's there and dismiss it completely, right? Huge problem in our industry. And just to show you a difference here, I've got a system here. It's got 75-degree return air. It's running about 13.5 SEER, I believe, and we're running like 33,000 BTUs. I'm a semi-blind up here, so I think those numbers are right. So about 33,500 BTUs. I'm literally going to just take a probe and I'm going to move it from the equipment. So this is testing at the equipment, right? We're just testing. The equipment's working great. All I'm going to do here is just move a probe over As soon as I move that probe over into truly testing the system, from the inlet of the return to the supply, now our 13 SEER system just dropped down to 10. And our BTU capacity went from 33,000 down to 24,000. So we lost 10,000 BTUs of cooling from duct leakage, from return air duct leakage, literally moving a probe. Now, that's significant to your customer, right? If we're testing at the wrong spot, we're going to miss this problem, okay? So that's one of the most important things, is truly test the system with MeasureQuick. Total external static pressure, we built static pressure testing into MeasureQuick now, and it will show you if your system has excessive static pressure. But this is a tricky one because a lot of people are measuring in the wrong locations. You'll see that your system's rated at a 1/2 inch of total external static pressure. You can actually go up to about 0.7 inches of static before you have significant energy losses, all right? I know it's rated at 1/2 inch. A lot of guys will say if it's above 1/2 inch, it fails, all right? But I'm telling you that you could fix it, and you get it down to 1/2 inch, so you get those 2/10, but you're not going to really see any substantial energy savings. Now, that said, you go above 0.7, and it's like a roller coaster going down, all right? Especially if you have a PSC blower motor. Anything on a PSC will really start to die. So when we're measuring this, okay, and you notice this is sort of to gray out a little bit here, but we want to measure before the coil, and we want to measure in the return. So it's post-filter and pre-coil, because this is a furnace, and the furnace is rated by itself. So it's anything external to the furnace is we want to measure, we want to include that in the measurement. So if you're measuring in your supply air duct and your return air duct, you are in completely the wrong space, because you're missing the pressure drop created by the filter, you're missing the pressure drop created by the coil. All right, so manometers are fairly new to our industry, and you got to make sure you're making your measurements in the right places. Again, let me see if I can get ahead here. There's an ideal static pressure budget. NCI is wonderful about teaching you about static pressure budgets. Rob's been teaching that for years and years and years. But this is pretty standard in our industry. We do 1/10 of an inch for the filter, 2/10 for the ducts, 2/10 for the evaporator. That's your total, okay? And there's a little process flow chart here explaining the ideal budget on here. An allowable static pressure budget, you could be in the 0.14, 0.28, 0.28. But the idea here, this is a budget. So if you have a little bit higher restricted, let's say, of an evaporator coil, then you can put in a little bit lower restriction of a filter. Or you can fix a lot of problems on the return side of the system. A lot of times we'll just double up the return air side. So it doesn't matter where you spend your budget, it's just that you stay within it, right? That's the key thing here. Downflow, upflow furnaces, just a couple more just showing where to measure the pre-coil static pressure. On an air handling unit, we actually do measure in the supply and the return, right? So a little bit different. So everybody in Florida, you've been doing it right. Everybody in north of Florida that has furnaces, make sure you're in the right locations. The key thing we want to ask now that we got all our probes in the right location, is what's your target? And are all your measurements in acceptable range, right? And this was a hard thing for me when I first started in the industry, because for years and years and years, I realized I was making measurements and writing them down on my work order, but I really didn't have a good understanding of what that measurement should be. In other words, I measure voltage. There's utilization voltage ranges, right? We are within the utilization range. What should our static pressure be? What should if you're hooking up gauges to a machine and you don't know exactly what the pressure should be before you hook the gauges up, why are you even measuring them? What difference does it make, right? Yet most of our industry, nobody's ever taught us how to actually calculate what those readings are. And MeasureQuick's got all those targets in there already tied in, so it'll do all those calculations for you. We pick up all the minor faults. So what we're doing here is we're picking up all the minor faults to aggregate into major faults, right? So it's got your built-in diagnostics. So you've all seen this diagnostic chart before, and it's all probability based, but we've taken this, expanded it out to over 100 different faults. So all these little yellow flags in the bottom are minor faults that aggregate into your major faults. Subsystem review. So after we figured out, hey, we got all these targets and we can do all this stuff, we found out, well, people were printing out reports that they were missing faults that we were seeing in there. So now we actually run an analysis on your electrical system. So I'm looking at your utilization voltage, I'm looking at your power factor, I'm looking at your air distribution system, your temperature split, your static pressures to make sure they're in right, your air filtration system to make sure the filter face velocity is right. Some things like your condensate drain, you're gonna have to put those in if they're subjective. Refrigerant charge, we're looking at superheat, we're looking at subcooling, we're looking at your high and low side pressure, your heat drivers. Outdoor equipment condition, indoor equipment condition, again, subjective, anything that would affect your cooling capacity and efficiency. So we actually run an analysis on that and do a pass-fail on those, completely automated. This is a company in Arizona that actually uses MeasureQuick for a quality control system. So they actually have about 14 monitors, and they have lead techs inside the office reviewing what their techs in the field are doing. So every single one of those, every system they put in, they're going out and testing. You can see the data from the field, you can see what faults your technician cleared, you can see all your performance calculations, you can pre-populate the projects, you can generate your past reports. Now this is probably my biggest pet peeve right now is I see a lot of reports come in where somebody didn't benchmark the system. And this benchmarking is capturing our personality. So after we commission a system, you want to be able to send a tech out who's got a lower skill level than you and have them be able to hook up MeasureQuick, and MeasureQuick will tell them if everything's in the correct target ranges and how that system's supposed to operate. And that's what benchmarking the system is all about. So once we get the charge right, we get the airflow right, we get everything dialed in the way we want it, right? Then what we're doing is we're capturing all the design temperature differences, the refrigerant charge, everything about that system, static pressure, model numbers, serial numbers, so that we can do non-evasive testing going forward, right? The whole idea behind this is we never need to hook up gauges to a system again. You guys think about this for just a minute. Everybody's got a home refrigerator at their house, right? If your wife called you from the trade show here and she said, hey, honey, the milk's not cold in the refrigerator, first thing you're going to do is you're going to say, well, did the kids leave the door open? Something blocking the door, right? You might say, well, we probably got to pull it out and vacuum behind it or vacuum underneath it, right? But the last thing anybody would do is walk out and go out their truck, get a set of piercing valves and tap into the system and see what the charge looks like, right? Because we know it's critically charged. We know it's probably not leaking out refrigerant. We know the refrigerator is going to last for 20 years without messing with the charge. Yet, that's the first thing technicians want to do. So if we benchmark the system with MeasureQuick, we can literally test it with just temperature probes, everything, and it'll tell you if you're in the right ranges going forward on there. So that's the beauty of non-evasive testing. So basically, once you optimize the operation, we're going to benchmark the system, and then it's going to line up the centers on there so we can do non-evasive testing and going forward. Reporting. Obviously, a lot of you have seen our standard report, which does our measurements and calculations, the pass, fails, corrective actions. But here in about 15 days or so, we're going to release this new report, which is a consumer forward-facing report that actually grades the system. So it does your measurements and calculations, your pass, fails, photo documentation, geolocation, but it also takes and runs an analysis on that system and actually grades based upon your heat transfer, your refrigerant charge, and your air distribution and filtration. And so your new installations, you should get somewhere between 95 and 100%, and it's pretty spot on there. Your old stuff, it's gonna allow you to show the customer, hey, here's where your system's at. It's operating at a 50% or 20% or whatever it's at, and here's where we could get it to. I'm going to pop into MeasureQuick here for just a minute. MeasureQuick has got a little bit of a new look to it, so you can see what's new, your dispatch projects, and then like here we're at Kalos right now, so you can see sort of where I'm standing. Here's that blue dot, and we can tap on, if we've been to a job before, it's going to pull it up. So you'll see when you benchmark a system, you store it in the cloud, you'll always know what systems are near you. So then you just click on it and you start your project. We've also made quick access to the projects if you want to do a quick test, like a multiple superheat test or evacuation. We've got your local projects, your support, latest videos, classic view of MeasureQuick, any of the quick tests that we have built in, like our temperature compensated pressure test, links to our MeasureQuick training. And everything on these screens now is all customizable. So if you want to get rid of the what's new after you see that and you want to hide it, you can hide it. You can move it down to the bottom so you can sort of make MeasureQuick work the way you want it to work for you. Because we have a lot of guys that do a lot of different things. So if you're a refrigeration mechanic and you want to redo your stuff, when you save that, it's going to pop up and you'll see that that's changed. Same thing when we're doing things like starting a new project. If we want to scroll down to the bottom here and edit the order of our projects now, you can edit them. So if you want to change it up the way you want it to work for you, you can set it up that way. Now, once we start a project in MeasureQuick, and let me just go back here, and I'm just going to start this Kalos one here and hit view. The idea here is you're going to select the type of project you want to do, and it's going to walk you in. You'll notice the UI is going to change. It's going to walk you in to show you how that system's operating, how it's currently scoring. So that vital score report where it's showing you 0 to 100%, it's going to start scoring your system. It's going to have your diagnostics built in. So let me just throw some demo data in here for just a minute, just so you can see that, what it's going to look like. And again, all this is we're just getting ready to roll it out here. So we'll go back. So here it's showing you that this system, which is actually a 13 SEER system, is operating with characteristics of a 6 to 9 SEER system. And if you look at your scoring there, in this particular case here, it's still scoring at a 92%. It's got a refrigerant charge issue. It's an overcharge. But there's been, believe it or not, you go, well, how come it's not flagging it a little bit lower on here? Part of it's because I don't have all the information put into the project, like the age of deficiency, so I literally just threw in some demo data. So if we put in a little bit more information, it's going to give us a little bit, the score is going to start to drop dramatically. But every one of those elements is based upon all of our industry studies. So there's probably about 13 algorithms running in the background that are taking into account your approach, your static pressure losses, your temperature split losses, age and efficiency losses, refrigerant charge losses. Refrigerant charge, believe it or not, has less of an impact than anything on there, especially an overcharge, slight overcharge, but that's what's causing the high head pressure on the machine. It's also doing your diagnostics. So what we're doing is taking you into scoring the system, the diagnostics on the system, and then this part of the project becomes secondary. But as we put in new measurements, let me just go in here, I'll test the system, and we'll just put some indoor measurements here, static here. So we'll clear out this 1/2 inch, and we'll just say that it's, we'll say it's 0.7 and 0.23, continue, and back, and we'll go back another one here, and it's gonna, well, share, and then this is where you're gonna export your vitals report. So this is where to do your scoring, explains how to arrive at that score, and then explains what the vitals report is. So all this stuff is built in, but we started to do some things that are more consumer forward facing so you can show when those systems are commissioned. And again, a lot of stuff here. Quick access to this green button down here is quick access to your support and your toolbox. We've also done some cool things as of recent. I don't know if you guys have caught it, but all your tools are auto-connecting now. So as soon as you open up MeasureQuick, your tools auto-connect. You don't have to go into the toolbox and connect anymore. So that'll all tie in. So a lot of new stuff coming in the next 15 days or so. So if you guys want to take a look at some of this, play around with some of it, you're welcome to. If you sign up for the survey, Joe will give you 25 qubits. Free bits, yep, free bits, so you can actually go through and set up some projects at your office or at your house or do whatever you want. If you're going to use MeasureQuick, one of the things that I would highly suggest that you do is go home, go to your home appliance, get your probes out, deploy them on your home system, sit on your back porch, crack open a beer, and just watch your system run for a few minutes, right? It is the best thing that you can do because, A, I will guarantee you that we will most assuredly find a problem on 7 out of 10 systems. Even though they're your systems, MeasureQuick will pick up a problem on your system. Secondarily, nobody's bugging you for a few minutes, and you can sit down and relax and sort of sink some of this in because there's a lot to learn with what we do for a living, right? MeasureQuick can be overwhelming for some people, and it's not intended to be, but it's just information we haven't thought of before. So when you get a minute to do that, it's going to be valuable. And the last thing is it's really going to help you once you fix the problems in your system. And you're going to either experience two things, or maybe one of them individually or both together. One will be increased comfort or a decreased utility bill, right? And once you experience those two things, you're going to understand why it's so important to take this from a system approach and not just try and do it at the equipment, right? It's so critical that we stop looking at this as equipment. When you guys get your new techs out there, don't even take a tool out of the toolbox until you walk through and look at everything. Maybe a nut driver so you can open up some panels, but look at everything before you start deploying the probes out there because the software is amazing software if you use it properly. If you just open up your toolbox and look at the readings on there, that's nifty, but you're missing a huge amount of opportunity that you can gain from using MeasureQuick. Any questions? We got about 2 minutes left. Yes, sir.
Testo 550S manifold.
So we are still working with Testo on getting those put in. So, but they are on our roadmap. CPS flow hood it's just got put on a roadmap so you can do air balancing. We'll do some air balancing with MeasureQuick. House Call Pro integration is on the way. We're wrapping up meetings with House Call Pro to get that going. TrueFlow Grid is in. You can actually use it right now, and it works with a MeasureQuick app. So if you want to get on the beta, we can show you how to get on beta and do some stuff with that. And please, if some of you guys would talk to Joe about doing training for MeasureQuick, if you want to learn to become a certified user or certified trainer, we've been having classes in our Ohio location. We've been filling them up. We don't have any openings in the classes till fall because they've just been, they've been full on there. But we are doing what's called like a train-to-trainer where we're bringing in guys that are basically supervisors or lead technicians, somebody at your office that we can train on MeasureQuick, get them very well versed, then they can take it back and get it implemented into your office. And it's been pretty successful so far.
Got a couple questions online.
All right.
So I got a question from Nathaniel. What if there were some issues with the original benchmark? Could you re-benchmark and correct the previous issue?
Yes, you can always re-benchmark a system. We're getting that set up in the cloud here shortly so that you can give your technicians permission to benchmark. So everything on our cloud side is tied to the app side. So if you have a younger tech, you don't want them to benchmark, and then you can do that, and also we're doing remote benchmark. So if you're a supervisor, you're remote viewing the data, and you want to remote capture the benchmark, you'll be able to do that.
Awesome. I got another one from Mike. Will the upcoming new AC Systems Vital report still be available in the free version?
It's not. It's never been in the free version, so it's only be on the paid side of the software. And that's something, we've been working on this project for 4 years now, and we got a lot of people. We've given a lot away, and we still want to continue to do that, and we still want to. But the paid side, the people that are actually using the MeasureQuick are realize you guys are subsidizing everybody else that's getting the paid side of it. So the more but the interesting thing is that it's free. MeasureQuick is absolutely free because anybody that's using it realizes that they're paying for a project that they're passing through to their customer so that it's not costing them anything the way it's designed to be used. And secondarily, it's adding revenue to their bottom line because they're finding problems that their technicians would have missed. So when you look at what it costs you for a callback, when you look at what it costs you for the missed opportunity, there's no cost to using MeasureQuick. Any block you have is a mental block with using MeasureQuick because it is absolutely free. I think you could do that. So the question is could you leave MeasureQuick, if you wanted to use MeasureQuick as a leave-behind tool, could you do that and leave a tablet on the job site, set of probes, and he's talking specifically SensiPredict is a limited set of probes that you could tap into and leave, and then maybe stream data from the tablet to the office. Yeah, I imagine you could set up, because we have customers that sort of use it like that now, but they're not using it as a permanent. They're using it as a temporary. When they have like a new compressor change out or something, they want to watch cycles or want to watch how the system's operating. They'll stream the data from MeasureQuick up to the cloud, and then they can, the stream will run for as long as you want to run it. So the question is, are we transitioning to any load calculation designs? And we do have places to input stuff from the software. Ed Jonowick's in the back there. We're working with ACA right now to actually be able to print a quality commissioning or quality installation certificate from MeasureQuick for your customer. So that's going to be coming in the future here at some point. We're working through the details on that right now. But that's going to be sort of integral to getting some of the information from the heat loss calculation, and specifically the required CFM and all that kind of stuff into MeasureQuick so you can commission against that. The question is, are we ever going to have a way that's not using qubits? And the problem we ran across was multifold. Number one is Apple and Google wanted to take 30% of everything that we run through through those platforms. So that was one of the reasons we pulled it off, is to avoid having the fees and stuff. But secondarily, it was we needed a way, everybody's devices, a lot of technicians' devices are their personal devices. So we needed a way to be able to share credits across all the personal devices and tie everybody into a central account so they could all pull from the same block of data, right? So that's really what that was designed for, is so that everybody, no matter whose device it is, and other things like Apple IDs and things like that, so there's just no way of using it across the company without having qubits. That was the solution for that. All right, well, thanks a lot for coming out. Appreciate the time.
Thanks for watching this video. Again, to find out everything we have going on, you can download the free HVAC School app on Android or on iPhone, or go to HVACRschool.com. And then specifically up in the top, you'll see events to find out more about upcoming symposiums. Hope to see you there.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to HVACRschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.